So in this video, we're looking at perfect squares and the difference of two squares. And let's start with perfect squares. So square numbers like 2 squared equal to 4, 15 squared equal to 225, and then x squared, which is equal to x times x, and our example, the perfect square, a plus b squared. Now these are all examples of perfect squares. So to expand a plus b squared, we multiply a plus b by a plus b, and we write it as double brackets, no multiplication between the brackets. So when we see double brackets, no multiplication between, we assume there's multiplication there. If it's not a multiplication, there will be another operation there, but if there's no operation, then it's times. So we use that. We're going to distribute that, expand that using what's called the distributive law. Okay, distributive law. And the method we use for the distributive law, I like to use the acronym FOIL. So that stands for first, outer, inner, and last. And I'm going to color code this process of each of these steps, so that's easier for you to follow along. So the first one is first. So the first terms in each of the brackets are going to multiply each other. So a times a is a squared. The outer ones, so in this case it's a times b, they're the outer terms. So a times b will give you ab. The inner terms are the most middle terms. So in this case it's b times a. And we should know that b times a is equal to ba, but you can also write that as ab. Then b times b is your last terms. So the last terms of both sets of brackets is b times b, so it's going to give you b squared. Once you get to this step, you can then simplify by collecting your like terms. So we have two there that are the same. So we have a squared plus 2ab plus b squared. And that is how you apply the distributive law to perfect squares. Now the difference of two squares is when we have a set of brackets with a subtraction in it. So we're taking the difference of the squares. And so in this example, instead of having terms to collect and add as like, our like terms will be subtracting each other. So our first terms give you a squared, a times negative b give you negative ab, b times a give you positive ab, b times negative b gives you negative b squared. Now we have negative ab plus ab, so we have negative 1 plus 1 will give you 0. So our simplified version this time is a squared minus b squared. So this is a perfect square. And this example is difference of two squares. Because you can see that we have a difference between a squared and b squared. So that's a difference of two squares. So now, if we have a look at a more applicable example, we have, let's say, x minus 4 squared. Whoops, put that bracket in the wrong spot. Now this is a difference of two squares. Or is it a perfect square? Well, we'll find out when we expand it. So we can write that as x minus 4 times x minus 4. X times x gives you x squared. X times negative 4, negative 4x. Negative 4x again. And then there's going to be positive 16. Negative 4 times negative 4 gives you positive 16. Collect your like terms. X squared, we have negative 4, take another 4, give you negative 8x plus 16. So you can see in this example, it's more of a perfect square because we have a trinomial answer. Okay. Then in example B, we have 2x plus 3 over 2. So again, that's 2x plus 3 times 2x plus 3. So 2x times 2x give you 4x squared. 2x times 3 gives you 6x. 3 times 2x gives you 6x. 3 times 3 gives you 9. 4x squared plus 12x plus 9. What about if I was to throw in 3x minus 2y and 3x plus 2y? Now you might want to pause the video here and go ahead and attempt this one by yourself. 3 times 3 gives you 9. X times x, x squared. 3x times 2y, 6xy. Negative 2y times 3x, negative 6xy. Negative 2y times positive 2y, negative 4y squared. Collect your like terms. Positive 6 take 6 gives you 0. So then we have 9x squared minus 4y squared. And that's your answer.